Okay, for the first question in this review, it wants us to label the opposite side and adjacent side to angle G and the hypotenuse. So the first thing you need to do is you need to place theta at angle G. And if you want to find the opposite side, draw a cross. That would be your opposite side. And your adjacent side would be the one beside. And your hypotenuse is always across from your right angle. So that would be your hypotenuse. So that's how you do the first question. For the second question, it wants us to find sine G, cosine G, and tangent G. So again, since you're looking at angle G, you want to put theta. You want to find sine G. That's going to label the opposite side, which would be RT, over the adjacent side, or hypotenuse, which would be GR. For the next one, it wants us to find cosine G. So if we want to find cosine G is the adjacent side over the hypotenuse. So adjacent would be GT over the hypotenuse, which again is GR. And then finally, it wants us to find the tangent. So tangent is going to compare the opposite side and the adjacent side. So the opposite side is RT, and the adjacent side is GT. So that's how you do the second problem. For the next problem, it wants us to find x, set up a proportion, and solve. So what we need to do to find x, we're going to compare this side and this side. Since we're given the angle 16, the angle 16 would be theta. So that's going to compare the opposite side and the hypotenuse. So when we compare the opposite side and the hypotenuse, that would be sine. So you need to set up your proportion. So sine 16 degrees equals the opposite side over the hypotenuse, which is 18. So to solve that, you want to make a proportion. So put that over 1. When we cross multiply, this tells me we need to multiply sine 16 times 18. So you're going to put it in your calculator. Sine 16 degrees times 18 is going to equal 4.96. So x equals 4.96. For the next question, it wants us to find x, set up a proportion, and solve. So let's let 74 be our theta. So if we put theta at 74, we're comparing the adjacent side and the hypotenuse. So that would be cosine. So we would set up a proportion. Cosine theta, which is 74 degrees, is going to equal the adjacent side, which is 19, over the hypotenuse, which is x. And again, we want to make it a proportion. So we put that over 1. If we look here, we're going to cross multiply. This tells us to multiply cosine 74 times x. So that means we're not going to multiply, we're going to divide. So in our calculator, we're going to put 19 divided by cosine 74. Remember, you always put the cosine last when you're dividing. So in my calculator, I'd say 19 divided by cosine 74. And that would tell me that x is going to equal 68.93. And that's the hypotenuse, so you know it needs to be larger than 19. The next question, again, wants us to find x. So let's find x. We're going to let theta equal 46. So if we let theta equal 46, we know we're going to find x, so we can use the opposite side and the adjacent side. So that would use tangent. So I would say tangent theta, which in this case is 46, equals the opposite side, which is 7, over the adjacent side, which is x. So we want to set up a proportion. So we're going to put it over 1. Again, when we cross multiply, that tells us to multiply tangent x times, or tangent 46 times x, which we can't put in the calculator, so we need to divide instead of multiply. So we're going to put in our calculator 7 divided by tangent 46. So if I say tangent divided by 7 divided by tangent 46, that's going to give me 6.75, which is going to round to 6.76. So x is going to be 6.76. The next question wants us to find the angle measure. So the angle is going to be theta, so that's going to be x. So I want to compare the adjacent side and the hypotenuse. So that will give me cosine. So I'm going to write cosine theta, because I don't know it, equals adjacent, which is 10, over hypotenuse, which is 15. But remember, whenever I want to find the angle, I have to press shift. So I'm going to press shift, cosine, 10 over 15. And that's going to tell me my answer is 48.19. So that's going to give me 48 degrees if I round. The next question, again, find the angle measure. So I'm going to put theta for the angle I want to find, which is labeled x. I notice that I'm comparing the opposite side and the adjacent side. So that's going to give me cosine. So I'm going to say cosine theta, which I don't know, equals the opposite side, which is 5, times the adjacent side. Oh, I messed up. Opposite and adjacent will be tangent. So I'm going to write tangent theta equals 5 over 12. So every time I want to find the angle, I've got to press shift. So I would need to press shift, tangent, 5 over 12. So I press shift, tangent, 5 divided by 12. And that gives me 22.6, which is going to be around to 23 degrees. So last one, find the angle measures. All right, so let's find x first. So I'm going to let theta equal x. So again, I'm going to find the opposite side and the adjacent side. So that's going to give me, again, tangent. So I say tangent theta, because I don't know the angle measure. Opposite is 16, adjacent is 10. So again, whenever I want to find the angle, I press shift, tangent, 16 over 10. And my answer is 57.99. So x is going to be 58 degrees. And if I want to find y, I could use the postulate that says that the acute angles of a right triangle are complementary. So to find angle y, all I need to do is 90 minus 58. So that would give me angle y would be 32 degrees. So I know both angles there. On this one, it wants me to solve the right triangle. So the first thing I like to do is find my angle. So if I want to find this angle right here, then I'm going to use the postulate that says opposite angles or acute angles of a right triangle are complementary. So I would say 90 minus 52 is going to give me 38 degrees. And that's going to give me my angle measure right here. Now if I want to find x next, I always use 52. I use the angle that it's given to me, so I'm going to let that be theta. I'm going to find x, which is adjacent, and I'm going to use the hypotenuse 10. So that tells me to use cosine. So I'm going to say cosine of theta, which is 52, is going to give me adjacent side, which is x, over hypotenuse, which is 10. And to solve it using a trigonometric ratio, I make it a proportion. This tells me to multiply cosine 52 times 10. So I use my calculator and I press cosine. Notice I don't press shift, times 10. And that's going to give me 6.15. That would be my measure for x. The only other thing I have left to find is I have to find y. So if I want to find y, I notice y is opposite theta. So if I can use opposite and hypotenuse, that would be sine. So I could say sine theta, which again is 52, equals the opposite side, which is y, over the hypotenuse is 10. So again, I want to make it a proportion to solve. So I'm going to cross multiply. That tells me to multiply sine 52 times 10. So I use my calculator, sine 52. Notice I didn't press shift because I'm not finding the angle. Times 10. and that gives me 7.88. So I found the missing angle, and I found the two missing sides. So I've solved the right triangle. An applied problem. A hot air balloon hovers 75 feet above the ground. The balloon is tethered to the ground with a rope that's 125 feet long. At what angle of elevation, E, is the rope attached to the ground? Round your answer to the nearest degree. So I want to find E, which is theta. So again, I know that this is my opposite side, and this is my hypotenuse. So the side that compares opposite and hypotenuse is sine. So I'm going to say sine theta equals the opposite side, which is 75, over the hypotenuse, which is 125. And since I'm looking for an angle, I've got to remember that I press shift. So in my calculator, I'm going to press shift, sine, 75 over 125, and I get 36.869, so that's going to be rounded to 37 degrees. So that's my angle of elevation. The last question's two-part question. It says a 14-foot ladder is leaning against the house. The angle formed by the ladder and the ground is 72 degrees. Part A. Determine the distance D from the base of the ladder to the house. Round to the nearest foot. So to find D, this is going to be my theta. And so this would be, D would be my adjacent side. 14 would be my hypotenuse. So that means I'm going to use cosine. So I would say cosine theta, which is 72 degrees, equals my adjacent side, which is D, over my hypotenuse is 14. So to solve a trigonometric ratio, I need to set up a proportion and cross multiply. That tells me to multiply cosine 72 and 14. So cosine 72 times 14 is 4.32 feet. So the ladder is 4.32 feet from the house. That's part A. Part B wants me to determine the height of the ladder reaches up the side of the house, round to the nearest foot. So I notice from 72, that would be my opposite side. So I'm going to compare my opposite side and my hypotenuse, which would be sine. So to answer B, I would say sine 72 equals my opposite side H over hypotenuse, which is 14. Again, I want to make it a proportion to solve the trigonometric ratio. So I'm going to multiply sine 72 times 15. So that gives me the height of the building is 13.3 feet. So I've answered this applied question. I found the distance from the ground and the height. So if you have any questions, please let me know. Our test is next Tuesday.